Here we have a SAT math problem. Okay, let's go to the question. The xy plane above shows 2 points of intersection of the graphs of a linear function and a quadratic function. The vertex of the graph of the quadratic function is at 3, negative 4, and r, s is one of the points of intersection of the graphs. What is the value of r? Okay, now let me consider the parabola. The parabola has two x-intercepts. So one is over here, the other one is over here. And this x-intercept is clearly the origin, that is 0, 0. What about the second x-intercept of the parabola? So that is the value of 6 on the x-axis. That is 6, 0 is the second x-intercept. Okay, how can I decide suddenly the second x-intercept of the parabola is 6, 0? Because I just looked at the x-coordinate of the vertex of the parabola. So here we have the vertex of the parabola, that is 3, negative 4. This vertex x-coordinate is 3. Usually the x-coordinate of the vertex of a parabola is the average of the two x-intercepts. Okay, here we have the x-intercept 0, then what x-intercept should be there so that the average of these two values equals to the x-coordinate of the vertex 3. So I must have 6 over here, so that when I find the average of this 0 and 6, it is equal to 3, which is the x-coordinate of the vertex. So from that I decide we have value 6 over here. Then the second x-intercept of the parabola is 6, 0. Okay, now we have 3 points on the line. One is 0, negative 6, and other one is r, s, and the third one is 6, 0. Okay, now what I'm going to do is I'm going to find the slope of this line using the 2 points 0, negative 6 and 6, 0. For that I consider this is x1, y1, and this one as x2, y2. And we know the formula to find slope of a line when 2 points are given, that is m equals to y2 negative y1 divided by x2 negative x1. Okay, m equals to the value of y2 is 0 negative, and the value of y1 is negative 6 over here. We can plug in negative 6 for y1, and for x2 we have 6 negative, and x1 is 0. Then we get m equals to negative times negative will become positive 6. 0 positive 6 is just 6. 6 negative 0 is 6. We get m equals to 1. Okay, now I got the slope of this line, that is the linear function, that is 1. Okay, again I'm going to find the slope of the same line. This time I'm going to use these 2 points r, s and 6, 0. So when I consider r, s as a first point, so I have to consider this r, s as x1, y1. Again I have to use the same slope formula what I have written over here, and I have to plug in the values for y2, y1, x2, x1. Okay, let me do it. M equals to y2 is the same value, that is 0. Negative. This time y1 is different, that is s, 0 negative s over, and x2 is 6, negative, x1 is r. And actually this m gives the slope of the line. Already we got the slope of the line, that is 1. So we can plug in 1 for m over here. Then I am getting 1 equals to 0 negative s is negative s over 6 negative r. Okay, now I can multiply both sides of this equation by 6 negative r to get out the denominator over here. Let me do it. 6 negative r over here, and here 6 negative r. Let me do it. Then this 6 negative r will cancel. 1 times 6 negative r is 6 negative r equals to negative s. Okay, now what I can do is I can multiply both sides of this equation by negative 1 to make this negative s as positive s. So let me do it. Negative 1 times 6 negative r equals to negative 1 times negative s. Negative 1 can be distributed to 6 and negative r. Then I'm getting negative 6 positive r equals to yes. Or this negative 6 positive r can be written as r negative 6 equals to s. Okay, I have solved for s in terms of r, that is I got s equals to r negative 6. Okay, now let me consider the parabola. The parabola has a vertex of 3, negative 4, and it opens up and it has two x-intercepts 0, 0, 6, 0. Okay, now let me get the equation of the parabola. So let me write the equation of the parabola in vertex form, that is y equals to a times x negative h whole square positive k. So here this h, k represents the vertex of the parabola, that is equal to 3, negative 4. So now what we can do is we can plug in 3 for h and negative 4 for k. Then I'm getting x negative 3 the whole square negative 4. Okay, still we need the value of the constant a so that the equation of the parabola will be complete. For that we can use one of the points on the parabola. Let me use this particular point 0, 0. It's on the parabola. So when I use this point 0, 0, both x and y values are 0. So it will be easier for me to do calculation of the value of a. Okay, now let me plug in this point 0, 0 into this equation, that is y is 0, a times x is also 0, 0 negative 3 the whole square negative 4. Then I'm getting 0 equals to a times negative 3 the whole square and negative 4. Then I'm getting 0 equals to negative 3 the whole square is 9, 9a negative 4. We can add 4 to both sides. When I add 4 to both sides, So this negative 4 positive 4 will cancel it. I'm getting 4 equals to 9a. Then let me divide both sides by 9. Then 9 will cancel. Then I'm getting 4 over 9 equals to a. Okay, I got the value of a, that is 4 over 9. In my next step, what I have to do is I have to plug in this 4 over 9 for a over here in this equation, so that the equation of the parabola will be complete. Okay, now let me erase all the stuff over here and continue the problem. Okay, here in the equation of the parabola, I got the value of a, that is 4 over 9. Let me plug in. Then I'm getting y equals to 4 over 9 times x negative 3. The whole square negative 4. And also we can consider this particular point r comma s on the parabola. So actually this is the point of intersection of the linear function and quadratic function. That is, we have this point r comma s on the line and the parabola as well. Anyways, since we have this point r comma s on the parabola, we can plug in this point into the equation of the parabola. That is, we can plug in this exponent r for x over here and this exponent y over here. And also we have to remember one more result we got in our previous working, that is r negative 6 equals to s. Okay, now let me plug in this point r comma s into the equation of the parabola. So the y coordinate s for y, then we have 4 over 9 times and for x we have to plug in r, that is r negative 3 the whole square negative 4. Okay, now our aim is to find the value of r, but here in this equation there are two unknowns, one is s and other one is r, but already we got the result for s, that is r negative 6. So we can plug in this r negative 6 for s over here. Then I'm getting r negative 6 equals to 4 over 9 times r negative 3 the whole square negative 4. Okay, now let me add 4 to both sides. When I add 4 to both sides, this negative 4 positive 4 will cancel. Then I'm getting r. When I combine negative 6 and positive 4, I'm getting negative 2. Then we get 4 over 9 times r negative 3 the whole square. Okay, let me erase this one and continue the problem. R negative 2 equals to 4 over 9 times r negative 3 the whole square. Okay, to get up the denominator 9 over here, I multiply both sides of this equation by 9. Let me do it on the left side and the right side as well. So this 9 will cancel out. We can distribute this 9 to r and negative 2. Then I'm getting 9r negative 9 times 2 is 18. Okay, here 4 times. We have r negative 3 the whole square. We can expand the square of the binomial over here. When I expand this, I am getting r square negative 6r positive 9. Then I'm getting 9r negative 18 equals to, we can distribute this 4 to this r square negative 6r and positive 9. Then I'm getting 4r square negative 24r positive 36. Okay, now let me subtract 9r from both sides. Let me do it, and also let me add 18 to both sides. Let me do it. So when I do so, this positive 9r negative 9r will cancel out, and negative 18 positive 18 will cancel. We get 0 on the left side. So we have 4r square. When I combine negative 24r and negative 9r, I am getting negative 33r. And here when I add positive 36 and positive 18, I am getting positive 54. Or the same equation can be written as 4r square negative 33r positive 54 equals to 0. Okay, here we have a quadratic equation. So I think we can try to solve this quadratic equation by factoring. For that, we have to multiply the constant term positive 54 by this 4. Then I'm getting positive 216. Now we have to get two factors over here, so that the product of the two factors equals to positive 216, and the sum of the two factors equals to the coefficient of r, that is negative 33. I think negative 24 and negative 9 will work. When I multiply negative 24 and negative 9, I am getting positive 216. When I add them, I am getting negative 33. Okay, here you may have a question. How can I get these two factors suddenly so that the product equals to positive 216 and the sum is equal to negative 33? Because what we can do is, the idea is we can try a one digit number over here, one digit number over here, so that when I multiply the two one-digit numbers, it has to give the result of 6 at the 6, because we have 6 at the ones place over here. So I tried just 2, 3 and 22, 33, something like that. Nothing works out. So I know that the 4 times 9 is 36. 36 means here we have 6, the digit 6 at the ones place, the same digit what we have over here at the ones place. Then I just tried with 24. So 24 times 9 is 216. When I add them, I'm getting 33. But here it has to be negative 33. So I took negative sign for both 24 and 9. Okay, now what I have is further I have to divide both these factors by the coefficient of r square, that is 4. Let me divide. So here divide. So when you divide 24 by 4, I am getting negative 6. But 9 is not divisible by 4. You can take this negative 9 over 4 as it is. Okay, now we have two values for r in this quadratic equation, because whenever I solve a quadratic equation, usually we get two solutions. So to get the first value of r, we have to change the sign of the first factor. Already it's -6. When you change the sign, it will become +6. Now to get the second value of r, I have to change the sign of the second factor. It's a -9/4. When I change the sign, it will become +9/4. Okay, so here when I divide this 9/4, what value do I get over here? So I am getting 2.25. So when I divide the 9/4, here I am getting two values for r. One is 6 and the other one is 2.25. Okay, now let me consider the point r comma s over here. R is the x coordinate, so corresponding to this point, the value on the x-axis over here must be r. Okay, so what value do we have to consider for r? 6 or 2.25? Already we know that 6 is over here. Then this value 2.25 should be over here. So therefore the value of r is 2.25, or it can be written as a fraction, that is 9/4.